Hello, this is Mr. Muller for lesson 1-4, powers and exponents. So this is kind of a review of what we did so far, and then just adding the difference between bases and exponents. So we do have some vocab that we need to go over first. So we need to know what a power is, what a base is, and what an exponent is. So a power is basically just this whole thing right here. This whole thing is called a power. And then within the power we have two other vocab words. So we have the base, which would be 3. So the base is the number that's used as the factor. And we have the exponent, which would be the 2. So how many times we're taking the base. Okay, so remember 3 to the second power does not mean 3 times 2. It means 3 times 3. So 3 2 times. Okay, kind of the same thing with going along with exponents. So if we say something is squared, that means it's to the second power. So if we're trying to figure out the area of a square, we're multiplying things twice. If we say something is cubed, then it's to the third power. Because if we're trying to figure out the area of a cube, we multiply each side 3 times. So a side times a side times a side. So that's why it's squared for 2 and cubed for 3. Okay, same rules still apply. If I have 2 positives or 2 negatives, my answer is going to be positive. If I have a positive and a negative, or negative and a positive, it's going to be negative. So kind of the same thing I said before, where if you have an even number of negatives, it's going to end up being positive, or if you have an odd number, it's going to end up being negative, which is right there. And this is basically the same thing going over, except now with a different graphic. And then here's some more examples. Let's get into some real ones. Alright, so here, this should be 3 to the second power. Alright, so if I have 3 rows of dots, that means I have 1, 2, 3, 1, 2, 3, 1, 2, 3. Another way to say that would be 3 to the second power. Or here I have 7 cubed. So if I want to figure out what my volume is for this cube, it would be 7 times 7 times 7, which would be 7 cubed. So that would give me the area of the box. Alright, if I have something like this, so that means -5 times -5 times -5. So a -5 times a -5 is going to be a positive 25, but times a -5 again, it's going to give you a -125. Okay, let's skip that -6 squared for a second and go down to this fraction 1. So I have 3/4 to the third power. That really just means 3/4 times 3/4 times 3/4. So that's really going to mean 3 times 3 times 3, which is 27, over 4 times 4 times 4, which is going to be 64. So fractions look a lot scarier than they are. You're really just taking 3 times, 4 3 times. Alright, with this -6 squared. Okay, so there's going to be a difference in our answer depending on where that negative sign is in front of it. Okay, so there's a difference between this problem you see in purple, and if you see something like with that -5. Okay, so this and this are going to have 2 different answers. Okay, so this means a positive 6 times a positive 6 with that negative sign out in front. So it's really going to be a -36. Okay, since that negative sign is out in front, that means that there's a negative out in front of my 6 there. So really, if I would draw parentheses here, it would look like this instead, which hopefully that helps. Okay, so this means 6 times 6, which is 36, times a negative. And if we remember, a negative just can't be out there by itself, so this has to be a -1. Just like if I have x, well, it's not really just an x by itself, it's really 1x. Okay, same thing with this negative sign. If I have a negative sign in front of parentheses, well, it's not really just a negative sign, it's really a -1. This one means -6 times -6, which, if I have 2 negatives, is going to give me a positive 36. So a little bit of a difference there, kind of confusing with where the negative sign is. Okay, when I have a problem like this, it wants me to write it, so it's kind of giving me the answer and I need to figure out the problem. So I know that my base is 8, and I don't know what my power is, so I'm going to put a question mark there. And I know my answer is 64. So for these problems, I need to figure out what power am I going to have. Okay, so then I would just start really at 1. So 8 to the first power is going to be 8. 8 to the second power is going to be 64. Sometimes it's just like that, where it's just 2 or 3 or 4 or 5. Sometimes it's a little more complex. So 2 would be my answer. Okay, this one I have a -3. To same thing, I don't know which power. Oops. Is going to equal 81. Again, I would start low. So this kind of gives me a hint, since I know that there's it's a positive 81 as my answer. I know my answer should be even, because I'm going to be taking -3 an even amount of times to get a positive answer. So if I do 1, 3 times 1, 3, or 3 times 1 is 3. If I do 2, 3 times 2 is 9. If I do 3, so 3 to the third power, it's going to be 27. And if I do 4, so 3 times 3 times 3 times 3, it's going to end up being 81. So that means -3 to the fourth power is going to give me 81. Some problems in the book just want you to rewrite it. So it'll ask you, what's another way to say 2 times 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 2? I think that was all of them. And you can just say 2 to the 8th power. Or you can say 256. So that might just ask you, how could you rewrite this? Let's do one more fraction one, just to make sure. Okay, so if I have 4/5 times 4/5, it really just says 4/5 squared. Okay, so it just means 4/5 2 times. I'm going to end up with 4 times 4 is 16. 5 times 5 is 25. Okay, fractions look a lot more difficult than they are. Okay, 4 times 4 is 16, 5 times 5 25. That's it, we're done.